Hi, everyone. I'm Susan Nash, AEPG, and I'm just really happy to welcome you to a packed program today. And it's so exciting. We're getting ready for our conference in Pittsburgh, and so this is like a little bit of a preview. We will be in Pittsburgh for the Abandoned, Orphaned, Idle, and Marginal Well Conference. And in anticipation with that, we have 4 speakers. We have Dwight Bulloch of Capstone, who's going to talk to us about key well integrity related gas testing, and the problem with false positives and false negatives. With Curtis Shuck, the Well Done Foundation, lessons learned and new developments. We also have Sunil Garg, who's an analytics tools for the business of orphan wells and marginal wells. And then we have Sally Lechin, who's here from Envana, and she will be Envana, rather, Software Solutions, and she will be helping us with facilitating the questions and answers. So I'd like you to make sure that you put your questions and answers in the Q&A area. It's easier to keep track of there than in chat. But if you want to put them in chat, that's fine too. We'll keep up. So at any rate, I'd like to get started and welcome Dwight to share your screen. Welcome, Dwight.
Thanks, Susan. Make sure everybody can see that
Yes.
Excellent. As I begin, I'd like to say thanks, Susan, for setting this up and giving us an opportunity to speak to the crowd. And I'm very much looking forward to the questions. I don't have a lot of slides today. I'm going to apologize ahead of time. The slides are more text heavy than I would like to. But as you can appreciate with some of the content, trying to show you pictures of false negatives is a bit of a challenge. So I'll just dive right in. And like I said, looking forward to answering questions. So see if this thing's going to work. So just a quick introduction about myself, and then we'll talk about what is well integrity related gas testing, what is a false positive, and what is a false negative, and then a little bit of details around that. So myself was the founder here at Capstone and president of Capstone Well Integrity. Been around the industry since 1995, heavily involved in well integrity related issues from minor leakage problems and solving downhole leaks, and working on the well as a well site supervisor and a manager in the office. But a ton of my background is actually blowout recovery related. So working on just about every significant well control event we've had in Canada in the last 25 years. So as far as Capstone goes, we are a well integrity management company. Quite literally, this is all we do, is test wells to see what's leaking, why they might be leaking, how badly they're leaking, and what needs to be done about it. We have a full consulting division that actually advises and recommends to our clients how to fix these sorts of problems as well. And then lastly, we do actually respond to and lead the work on blowouts. Interestingly, blowouts in 2023 in Canada, we responded to 6 different well control and blowout events here in Canada. And 3 of the 6 were actually well integrity related issues. Had nothing to do with rigs or well work. It was actually ongoing wells. So what is well integrity related gas testing? In its most simple term, I would say it's testing that's performed at surface to determine if there's a problem downhole. We like this graphic. It's a very simplified graphic for most American wells in that you don't find an intermediate casing string. But what you will see is the little red arrows pointing to the 2 different most common gas flow paths that we deal with. One being the surface casing vent flow or sustained casing pressure that you'll find on intermediate strings, and a lot of the issues we're starting to assist clients with down south. The other one being gas migration. There's certain areas of Alberta, especially the northeast corner of our province, where gas migration is a significant and ongoing issue. And the regulator here actually has a mandatory testing area where this has to be done. We do a lot of this work. In 2023, here in Western Canada, we tested over 4,000 wells for these issues. We're busy running around collecting a lot of data. So gas testing examples. On the left of the screen, you'll see a Capstone employee. If you have a keen eye, you can just make out in the background that is actually the skyline of the city of Calgary. We have a handful of wells that we test inside the airport property every year. So this is actually on the ground here at YYC. The red cone you'll see here in the bottom is actually was the original well location. Obviously been cut, capped, and buried. We do a ton of that testing on an annual basis. In the middle, you'll see what's known as the infamous Canadian bubble test. The regulator here has a standard test. We have to test casing strings for flow with a 10-minute test in 1 inch of water, and you can have no flow for 10 minutes. I hear that there's some eyes rolled and there's probably some groaning already in the screen that this is the Canadian standard. It's been the standard for a long time. A lot of argument as to why it should or shouldn't be the standard. Not my point today to get into the debate as to whether it's the right tool, but we'll talk about it. And on the right, you see our fancy vent meter gizmo, which is monitoring the flow. So gas migration testing process. This is the process we follow. I know there's a couple of folks I noticed on the participant list with the DEP in Pennsylvania, and I've had some conversations with them around this process. What you see on the right is actually a portion of our report that we generate and provide to our clients. So what we do is we perform a measurement at surface, so literally sampling for gas right at the surface. And we do that in 1 meter increments in this radial cardinal points of the compass. Typically, we do 48 test points per well. Once we have those readings, and this chart you see on the right is an actual scrubbed report that I pulled from one of our clients. You'll see the red circles are indicating a reading of 100 parts per million of methane or more. Once we identify surface readings, then we'll actually start to do subsurface readings. So we actually drill down on these same points and actually start taking readings below surface. And I would say as a general rule of thumb, if we're seeing, over 100 parts per million methane at surface, we'll get into percentage methane below surface once we start drilling some test wells. We have these ability to sample this as well and pull isotope analysis and those sorts of things with lab partners that we use all over. So what's a false positive? This is a definition out of Dwight's head, so feel free to challenge it, tweak it, change it, whatever you like. But in our case, as we speak to our clients, we talk about an indication of gas presence either in an annuli or within the soil that is not actually wellbore related gas, or is only present due to a surface correctable problem, not due to a downhole failure. So I put this little snippet out of one of our lab partners' reports, and it's explaining the difference between thermogenic and biogenic gas. Again, that area of northern Alberta, where it's an ongoing problem, biogenic gas is something we deal with pretty regularly. So you have a really high organic compounds in the soil, they're decomposing and they're creating biogenic gas instead of thermogenic gas. So surface casing or sustained casing pressure testing, the process, the bubble test. Is it the right tool for the job? I'll leave for you guys to decide that. It's simply a yes or no tool to indicate flow that can overcome a hydrostatic pressure of 1 inch of water. We use a highly sensitive methane monitor that can measure from 0 parts per million to percentage by volume. We recommend that to validate the pressure or the presence of gas in the annulus. If there's any doubt as to the result of the well history, bubble testing information, methane presence, we recommend you install a monitoring system for a period of time to have confidence that there's no problem. We've seen wells stay dormant for days to come alive and flow for a few hours periodically with enough gas to be a problem post-cut and cap operations. So how does a false positive happen? I mentioned the biogenic versus thermogenic process. We've seen that a lot where we come in subsequent to an operator doing their own testing or hiring another firm to go in and do the testing. And we've been able to rule out the fact that it wasn't actually the well leaking. The most common one we see is gas present because of wellhead leakage. Failed casing seals. I think there's been entirely too many wells that have been programmed and a rig mobilized to go and do remedial repairs when the problem was right in the wellhead. And that's an easily identifiable problem on location most of the time. And then lastly, inaccurate readings due to operator error, where you have, and I don't mean this to be in a harsh term, but an incompetent operator, which just doesn't understand what he's testing, why he's testing it, and what he should be looking for. What are the consequences of false positives? Again, text heavy slide, but I think to key in Inaccurate liability costs. If you are recording a bunch of wells in your field that have vent flow or gas migration problems that are not actually real, you're carrying higher ARO liabilities in your balance sheet than you really should be. The next one is regulator pressure to fix non-existent problems. We've actually had clients that report these issues to the regulator and say, I've got a casing vent flow, or I've got a gas migration problem. It wasn't actually there. And I'm sure there's a ton of people on this call that can attest to how difficult that is to undo. Once you've reported a problem and then try to explain to the regulator it's not actually a problem, that's a tough conversation. Incorrect budgeting and prioritization. Some companies will prioritize problem wells. The lion's share of the clients that I find actually postpone their problem wells. But if you're dealing with inaccurate data in either case, that's not the best choice. Improper well work planning, similar to above, your budgeting and prioritization. But when you're planning work to do that doesn't necessarily need to be done, there's a cost implication to that. You're doing much more programming and thinking your way through execution of wells that didn't actually have a problem that needed to be solved. There's a cost to that. And I think the last one's really interesting, is this reputation impact. When we show leaking wells as a problem to the regulator and to the public, it starts to erode their confidence in our ability to actually understand our business and know what's going on in our wells. False negatives. This is a much more interesting story, a much more common problem, I would say, in our industry. And this is a successful test wherein the well does not show a gas present. When there is a missed indicator or an intermittent problem not found during testing, but the well is leaking or will leak gas to surface. So if you can make it out in that photo, you can see that there's clearly some distressed crop occurring in that well. The yellow pin locator is indicating where the actual well was located. That's an obvious problem. That's a problem that more than likely was missed either during or prior to the abandonment process. False negatives, how do they happen? Again, incompetent testing operators, incorrect or defective equipment. We've seen number of wells where people just take their personal LEL monitor and hold that on the ground and think that that's going to be a suitable test. And it just isn't. It's not the right tool for the job. And you end up with mistakes like you see here on the right. The next one is intermittent flow that's not present during testing. This is a common problem. Our wells will breathe and fluctuate. I can show you data after data after data of wells that will breathe and fluctuate by ambient temperature and atmospheric pressure. So depending on the actual atmospheric conditions of the day that you're doing the test may impact whether or not your test passes or fails. And then the last one is what I call the elephant in the room, or the ugly little secret that we don't necessarily want to talk about, is tester bias. I've personally witnessed, observed it many times in my years in the field, where testers are trying to ensure a pass, thinking that they're doing the operator or the owner of the well a favor. You start to see bubbles in that 9th minute and going, I'll call that 10 minutes on my report and good enough. And they think they're doing a favor, and they're not. They're actually just kicking the can down the road to a much more expensive problem later. And again, an example here on the right, this was a well that was cut, capped, and buried that clearly has some issues. What are the consequences? The exact same main bullets as I had for the false positives. You end up with inaccurate liability costs in your balance sheet. You may have problems that you're not actually tracking. Regulator reputation issues. This is an ongoing issue when the regulator finds problems that the operator didn't. And when that happens, it starts to erode their trust and you get subjected to higher scrutiny. If the operator can't trust you to measure your wells and adequately report whether there's a problem, they will start come out and do more and more inspections. Incorrect budgeting and prioritization, exact same as the last bullet on the false positives. You have the wrong information to work from. The next one gets really expensive, and we've seen this too many times to count. When you find the leak, once you start performing the well work, your rig is literally standing on the hole, and then you discover there's a well integrity issue. That's a really expensive way to execute that work. You're burning through sometimes $2,500 or $5,000 an hour, and you're scrambling to catch up to the fact that now you're trying to do remedial cementing and perforating and whatever else you may be trying to fix. That's an expensive way to go about that. But on top of that, we find, as I said, the extreme where the leak is missed until after the cut and cap. We get called in often with the cut and cap crew. because in most regulator jurisdictions here in Canada, this test has to be done prior to cut and cap. So the rig and the well work execution guys have all left. The cut and cap crew shows up. Now they realize there hasn't been a test done. They call us in and we'll find the well is actually failing. Worst case scenario is the cut and cap crew misses it, cut cap, bury the well. And now you have a very expensive re-entry to get back into that well. And we do, unfortunately, way too many of that every year here, where we get called out to go back into a well that's going to get re-entered. Again, industry reputation impact. That's a bad look for our industry when we have leaking wells and we're not finding it ourselves. And that hinders our reputation and prevents us from being proper operators to the public. So I just got a few random pictures before I round up. This was a project from as recently as last November in Northern British Columbia. So this was a cut and capped abandoned well. The regulator went out to do their annual inspection and found the picture on the left. The post is literally just a sign that marks where that well location is. On the right was our crew executing the re-entry of that well. And at this point, they'd actually ignited that gas flow. You can see what a lazy flame, what a minor amount of gas flow that's there. But that small gas flow was 8.5% H2S. And that was what was coming to surface on the left. On the left, you'll see a location in northern Alberta where there was a well that had been cut and capped and buried. The town's grown around that location. You can literally see the playground in the background. This well we deal with on, I think once a quarter, we go out and sample around this well. It's an ongoing issue with that problem. And you can clearly see the vegetation distress. Same as the one on the right. And as the title of my slide says, it's the wrong way to do things. Finding these problems is a really expensive way to do it. So as I take questions, I'll leave this slide up. This is one of the most extreme examples of a surface casing vent flow I've ever dealt with in my career. This is northern Alberta in the early 2000s. As you can imagine, that's several million a day gas flow coming out of a surface casing vent with 33% H2S. So that's 330,000 parts per million of H2S on a location that did not have a road. We were literally choppering in and out of that site. That's the most extreme one I've worked on in my career. It's not the best way for us to do our work. That's the end of my slides.
Well, thank you. Wow. I mean, the part about the methane is one thing, but when you add in the H2S, is incredible. Well, we'll save the questions till the end. So I'd like to invite Curtis Shuck to join and to share his slides. Welcome, Curtis.
Hey, thanks, Susan. I appreciate it. Let's see if we can make this all happen here. Let me know when you get a visual.
Yes.
Got it, huh? It's amazing when technology works. Well, now I got to get the darn thing to advance. That'll be the next part. There we go. Wonderful. Well, good morning, everyone, and thanks for the opportunity to join you today. My name is Curtis Shuck, and I'm the chairman of the Well Done Foundation, a nonprofit formed in 2019, based in Bozeman, Montana, Hobbs, New Mexico, Oil City, Louisiana, and now right here in Santa Barbara County, California. This is a little bit about sort of the background on our mission. Pretty straightforward. This happened, I happened across my first Orphan well in 2019. Couldn't believe my eyes. For me, the biggest impact was the reflection back onto the industry and the fact that this, in any universe, this wasn't good. Didn't matter whether you were a climate crusader or a climate denier or a Republican or Democrat. This is just isn't the right way to do business. And so that there started off our journey. In the left there, that's the second grade class from Sunburst, Montana on Earth Day in 2021. And that's essentially why we do what we do, right? As those kids are right there. and every other kid that is looking to have an amazing future. So it's all about, again, about leaving things better than the way that we found them. Today, we're active in 14 states across the U.S. We have been working on any number of wells, from an urban setting to, extremely remote, every crazy imaginable situation. Just about the time you think you've seen it all, here comes the next well. And, from all levels of the social and economic spectrum. In fact, we're working on a location right now here in Santa Barbara County that's actually in the middle of a homeless encampment. And so that brings up a whole new layer of sensitivities in terms of working around the neighbors, if you would, in the neighborhood. So anyway, this is just a couple of shots here. We started measuring beyond sort of our program from the obvious work that we did to start off the ACR program to develop a carbon credit strategy and to help augment the funding of this orphan well problem. Remember, in 2019, when we began, there was no money. It was everybody's dirty little secret. Nobody wanted to talk about it, and nobody had any money to fix it. So we knew we needed something to go beyond our car washes and bake sales to help to fund the orphan well program. And so that's when we started down the path of sponsoring the methodology with the American Carbon Registry. And so initially our testing and methane quantification was focused around that level of confidence and that level of verifiability. Well, in 2022, we were contracted by the state of New Mexico to start measuring methane for them just before the IIJA funds were released. They wanted to get a jump on it. And so we've actually been measuring in the state of New Mexico, like I said, since August of 2022. We've measured literally hundreds and hundreds of wells for them. Today, the state of New Mexico has the most robust methane quantification results and data of any other state. To date, we've measured literally thousands of wells across the U.S. We've measured in Appalachia, we've measured down in the Gulf Coast, in the Southwest, essentially from border to border and coast to coast. And one of the things that we're going to talk a little bit about today are really around those lessons learned. And I'm glad this discussion of H2S came up today, because as you can see in this photo here, that's something we deal with every day in the Permian Basin. It's just a matter of fact, right? You don't go into the field without an SCBA and a backup tank, and you don't go out without a partner. And, we have air trailers that are integrated into our program, and that's just the way that you do business there. Well, I would tell you that even in areas where you don't expect it, you should expect it. And I'll give you a prime example. I was driving off of an orphan well location the other night in southeast New Mexico. Got finished up with the team at about 7 p.m. So it was well into dark. The wind had laid down to about nothing. It was cooling off, as you can imagine. And as we were driving off of the location in the cab of the pickup truck, our H2S alarm started to go off, which was quite alarming because the gas level was overwhelming even in the cab of the pickup truck. We were nowhere near an orphan well. We were nowhere near a well at all. So we drove and passed that, obviously at a little accelerated rate, until the alarm stopped. Got out, walked back to the location, and the alarm started going off again. And again, the gas presence was literally almost overwhelming. And so we ran back to the truck. We got the location dialed in and reported that evening to the the Department of Oil and Gas in New Mexico. Turns out it was actually a sour gas pipeline leak. And so one of the takeaways there is that even when you think you're safe, you need to make sure that you take precautions. And because as you know, H2S is unforgiving. And as it turns out, those elevated levels that were measured the next day, even in the wind, the gas coming up through the soil were well above the safe working limits. And I ended up taking a few days out of the field there just to allow myself to recover. But that was a real deal. And again, like I said, we weren't even at an orphan well location. So one of the things that we want to talk about today is using the right tool for the job. And the reality is anybody who's in the field measuring gas, measuring methane, specifically, whether it's with the IIJA or for the IIJA, federal programs for the Department of Interior through each of the individual states, whether it's for orphan well work that you may be doing to help to generate carbon offsets, or you're working for an operator who is looking at doing some wellbore integrity testing. The reality is that this is a hazardous environment, right? This is dangerous infrastructure with an elevated level of risk of fire and explosion, period, flat at the end. Don't be fooled by all the pretty pictures that I take and post. And I get accused of that all the time, of sort of glorifying the work that we do just with these, images that make things look nicer than they are. The reality is that this is deadly infrastructure. These wells, especially those orphan wells, that infrastructure has either failed or is failing. And just because that well isn't out of control today doesn't mean that if a cow rubs up against it the wrong way, if the farmer whacks it with a combine next time he's taking another turn in the field, or the wind blows just the right way, that there's not going to be a problem. We were on a location again in New Mexico a couple of weeks ago, where we were doing some measurement and monitoring, and got our reports back into the state. And literally 2 weeks after the rancher reported that one of the wells that was directly adjacent to the one that we were measuring on, which was actually an injection well, had decided to uncork itself and start uninjecting its contents. And so this stuff is out there every day. And so again, a word of caution is critical. In this particular shot that you see here, this is where we were actually measuring on an orphan well as the rig was getting stood up around it. We wanted to make sure that we got a good 12-hour test prior to that. The key here is the fact that if you look at that certification in the center of the photograph there from Intertech, that is a Zone 0 certification, or Class 1 Division 1 certification. And what that means is that this equipment is intrinsically safe and is certified to be in the hazardous area. And the hazardous area is anywhere within 10 meters of the wellhead or the location where the gas is present. This particular well, gas levels were well in exceedance of 800,000 parts per million, or 80% methane gas, plus all of the other gnarly constituents that go along with that. But in terms of explosivity and pressure, all of the elements were there for having a really bad day. And so it's super critical, again, to select the correct tool for the job. Now, one of the things that we notice in the field is that there isn't a lot of enforcement that goes on, right? Regulatory agencies aren't certifying that your equipment is fit for purpose and is the right tool for the job. The only place where I've really seen that is on active operator sites, and I appreciate them with their attention to detail. So all of these other locations, especially on the Orphan well side, they're all kind of left up to the honor system. And you know what? That's all good and fine, and all the way up until it's not, right? And then all of a sudden, there's a big problem. And I guarantee you that that's when the fingers start to get pointed and the lawyers start to come out and the hard questions start to get asked about proper tools, proper training, and all of those things. And that is not the time to put your program together. I guarantee you that. This is a shot here of an Orphan well measuring in New Mexico, running the gas through a scrubber, which is actually, call it a methane minion, but it's to take any of the fluid or moisture out of the gas before it actually enters into the measurement meter there. Here's another shot where we're actually working on a well in southeast New Mexico in the neighborhood. You see the proximity of the homes in the background and actually a mobile home park that's less than 100 feet away. This particular well came from, again, courtesy of a defunct operator and was just ripping gas to the atmosphere. So we're in there working continuously with the plugging crews to not only do the pre-plug methane emission certification, but also through the process to see what the stage integrity is of those plugs as they're coming up out of the hole. And the stakes are high, right? I mean, you can see just based on the proximity of these homes and obviously the workers on location that, again, this is no joke. So your equipment's got to be fit for purpose. Again, it's got to have the right certification, and your people have to have the appropriate training, certification, and testing. This is just another shot of that particular well there in Carlsbad, New Mexico. And again, just a highlight here of what needs to happen. So if this sticker or a UL listing or something visible isn't on your equipment that you're deploying on a well site, and I don't care whether it's an Orphan well or one that you're doing for an operator or for doing for yourself, if it doesn't have that sticker on it, here's a pro tip: leave it in the pickup truck, right? And go find one that is, or give us a call and we'll get you hooked up with the right equipment. And here's the problem, right? Here's a shot of some of the area we're working in right now in Kern County, California, right? So you can see the level of density there in terms of well spacing and proximity to other activity. So one misstep on a well in a field like that can have catastrophic results to the extent of the potential for injury or death, not to mention the level of potential property damage and liability exposure, again, if you're not using the appropriate equipment. I wanted to bring up a case study now since we're talking about lessons learned. So here is another well that we were measuring on recently in Carlsbad, New Mexico. I don't know if you guys have ever seen any of our Carbon Wildcat posts, but that's kind of my little series of when I get bored out there in the field and want to share some information, I'll pop up the phone and film a short little clip. Well, this is a well that we had identified in Carlsbad, New Mexico, and the name of the clip at the end of the day was Angry Well. And this well was going off, right? Leaking extensive amounts of gas at the surface. We were obviously measuring that pre-plugging to report back to the state and to give the plugging crew a heads up. What we do in addition to the pre-plugging methane assessment is we also then issue kind of a quick little down and dirty safety assessment to the plug-in crews about what they're going to maybe see next. So obviously, this had a big exclamation point on it in terms of the level of risk, because not only was there a significant amount of stored energy, the CH4 or the methane levels were extremely high, but there was also an elevated level of H2S on this well. So this is the angry well. We gave the crew a heads up. It was about a week later that this showed up on TikTok, and I'm sure you guys have seen this. I didn't actually run the video here because of some of the language that was used in it. But what happened was the crew was in the midst of trying to put the BOP on this well, and there was a few steps that apparently didn't get taken in the right way, and so they lost well control. And so they lost well control, and there were also some ignition sources that were within the safety zone. And again, whether it's a testing device that doesn't have the right certification, or whether it's some other ignition source, and in this case, it was another ignition source, but the same thing. It was a device that wasn't approved for use within that Zone 0 area. And here's the result. The result was that that rig, who just a few weeks prior, we had been on location with this very same crew on another orphan well. And this is
Curtis, I don't mean to jump in, but you got 2 minutes.
Okay, yep, this was the outcome here. And so there's a lot at stake, right? A lot at stake to make sure that you're doing the right thing with the right equipment. So I wanted to move past that because we want to talk about this training and testing program that we've initiated, because again, as a requirement of the Department of Interior, you've got to be certified as a qualified measurement specialist. And so that's something that is of high focus to us, not only for safety, but also for the quality of the data. We call this Paychecks with a Purpose. And we've got lots of examples of the data that we are collecting across the country. But the key behind all of that is training and testing, so that we don't end up with a problem at the end of the day. And I think with that, Susan, I'll go ahead and wrap up.
Perfect. That was great. Well, so interesting. And we'll move over to Sunil Garg right now. So we'll have time to make his presentation and have some time for questions. So thank you. And oh man, those were fortunate. Well, I was just thinking, thankfully no one got hurt. That's all I could think of when I was watching that.
Absolutely.
So welcome, Sunil.
Thank you, Susan. So I will go ahead and share my screen.
Perfect.
Okay, and now you should be able to see my presentation. So Dwight started the session, and one of the things he pointed out was the incorrect budget estimate for ARO, right? And then Curtis described, lot of factors involved in plugging the orphan wells. So what I want to talk about is, in order to make sure that the orphan wells are plugged properly and the companies make a proper provision for abandoning the wells and the facilities associated with it, they need to make provision of sufficient budget, right? So what I wanted to talk about a little bit is a solution and a methodology that DataVedik and Ryder Scott developed for the annual liability and budget forecasting for decommissioning assets. So just a little bit of introduction about myself. I'm the founder and CEO of DataVedik. DataVedik is a Houston-based AI/ML company. We are focused on sustainable living, and we are building a technology platform for energy industry using a combination of oil and gas domain expertise, data science, and software engineering. Long experience in oil and gas industry. Almost this is my 30th year, in fact, of being in the oil and gas, and primarily in the data management and machine learning and AI space. So overall, when we look at the budget abandonment, right, abandonment budget, the very first thing that we look at is a graduated retirement of assets with time. And this is how roughly the timeline looks like, right? At some point of time, based on the various factors that we will talk about, you decide to abandon a well. And then as the wells associated with a pad get abandoned, at some point of time, you have no well basically which is active on a pad, so it is time to retire that pad. And along with the retirement of the pad, the associated equipment and facilities, compressors, pipelines. So all of those facilities need to be abandoned as well or retired as well. Right? And that's why the timeline looks exactly like this. And as you can see at the bottom, the budget required for each one of this, right? It also increases basically because abandoning a well is a simpler process than abandoning the whole pad, which is a simpler process than abandoning all of the equipment and facilities associated with it. And hence the cost also increases over a period of time. And this is another reason why it is important to account for all of these activities, because sometimes people think about, plugging orphan wells as the primary activity. That's not just, the process doesn't end there, right? There are more things that need to be abandoned and properly plugged in and, kind of stored away. So why we are talking about asset retirement obligations? There are various reasons, and depending on, whether an operator is operating a well or, they are a non-operating partner of a well or they are operating a particular facilities, there are different types of obligations. So we look at those obligations from three different angles and lenses. The very first one is the operator angle, right? The operator who is operating those wells, right? For them, asset performance is typically the primary criteria, right? Are their production volumes increasing or are they going down? Because at some point of time, if it becomes uneconomical to produce, it's time to think about retiring that well. Are there greenhouse emissions increasing, right? That can be another factor in the future which will decide whether the well should continue to produce or should it be abandoned. And there are several such factors from an operator perspective. From a lease owner perspective, right, there might be issues around, are they getting sufficient revenue from this land, right? If not, then they might have some obligations in order to make sure that the wells and facilities are abandoned. If I look at, the government, the railroad commissions, they have regulatory compliance requirements, right? One of which is safety, right? Are the activities, the production that is being done from those wells, can it be continued to be done safely, right? Again, emissions is one of the other factors. Is it emitting too much of greenhouse emissions? And at that point of time, there may be regulatory compliance requirement to abandon those wells and facilities. So those are some of the criteria that people look at from their own perspective in order to decide why the asset retirement has to be done. Right? The key input data that you need in order to come up with that budget, right? There is a process that you need to come up with, and for that process, you need a lot of data. I put some primary key input data types here, including, let's say, the lease related data, the lease contracts, the wells, the details of those wells, the pads with which the wells are associated, pipelines and other facilities that are connected to those pads, production data, greenhouse emissions data. These are all the various data types, that play a role in determining when the wells and facilities should be abandoned and what is the budget required for that abandonment. Financial constraints may be other factors basically that come into play while making that decision. So once you have all this data, right? So while developing the solution, I want to talk about a little bit about the challenges that will typically come in order to develop such a solution. So on the left, you can see, we have listed a bunch of sources, and I've just, to anonymize them, I've just put them as source 1 to source 7. These could be sources sitting inside the company. These are different sources of the data or different data repositories that are sitting either inside the company, or some of them may be even outside. Some of that may be the data that we are tapping from the regulatory bodies like the Railroad Commission. And it may also be the data coming from third-party tools and solutions. So one of the primary challenges is to bring all this data together, process the data, QC the data, merge it all together, and come up with some sort of master data and transactional data based on which we can then develop and run the algorithm which will forecast that annual asset retirement budget. The other challenge is to also make sure that while doing this process, that the regulatory compliance requirements with whatever, and the rules may differ from state to state and from the regulatory body to another regulatory body, that those regulatory compliance requirements are adhered to, and that too in a timely fashion. Right? So those are a couple of challenges, that are associated with kind of building and deploying such a solution. So I just wanted to now show you how we kind of came up with, the methodology and the solution, right? So the very first thing, like I said, bringing the data together. So as you can see the various data types, you can assume that some of these data types, are coming from same repository. Some of them are in different repositories. Those repositories may have all come from different vendors. And like I said, there may be external tools involved, right? So first thing is to bring all these data together and then match and merge the data in order to create what we call as a master data for the wells and the facilities. Once that master data is in place, we put together the transaction data. So production volumes, greenhouse emissions data, that's all transaction data associated to those wells and facilities. Once that is done, then we developed basically the asset retirement algorithm, which again, as I showed in my first slide, it kind of predicts and forecasts the budget for the various asset requirements over a period of time. Let's say for next 20 years, 30 years, 40 years, you can run it on a graduated timeline. And you can also run this algorithm, let's say every year in order to refresh those forecasts. Because as you know more about the actual production and the actual greenhouse emissions, right, and the state of and condition of those wells and facilities, some of those numbers will undergo revisions over a period of time. So that's why it's important that it does not need to be a static algorithm. It needs to be an algorithm which takes care of the current state and then recalculates those budgets. And then the key factor for using such a solution in order to do the actual budgeting is an intuitive UI, which kind of walks the operator through the process of doing this, right? Including showing, how the various data types are being combined together and are being used for calculating that budget obligations. And also, allowing them to run various what-if scenarios in case some of the costs involved in the various activities that take place during the abandonment, the cost may go, up over a period of time. They may also go down depending on, how the oil and gas market is doing, what is the availability of the labor, what is the availability of the various materials involved in the well abandonment. Right? So you can run some what if scenarios to say, in future, if cost change due to some reason, what would be the impact on the budget? Right? So all of that is kind of, you can say an integrated process, starting with the data pipelines to bring together the data and merge the data together. And the next step in that pipeline is typically running the algorithm in order to come up with the timeline and budget for the asset retirement obligations. And the last step is basically a UI, which allows the users, the end users of this process, which is the users who are going to do the budgeting, which allows them to go through this process in an intuitive manner and run the what-if scenarios. Okay. The end result of this, the kind of benefits that this kind of solution brings in is, very first thing is compliance, right? So compliance with the lease owners requirements, compliance with the government regulations, right? So both are very important, right? So it helps to bring about that compliance, and it is facilitated by the timely collection of the data in a modern data platform. So essentially what we did with the data pipelines and bringing that data together in a data lake is facilitating that whole solution. Right? It also allows you to do budget forecasts in a, you can say, in a transparent and a verifiable manner. So this allows you to do some auditing on those costs as well, right? And at the end of the day, right, it allows you to make effective and faster decision making. Because, without a solution like this, if you are overestimating the budget, then you are essentially, reserving the capital which could be used more productively elsewhere. for revenue generation purposes. And if you're underestimating the budget, then you could put a severe, you can say, stress on the financials of the company for in a particular year where you have underestimated the budget, right? So essentially, this kind of solution allows you to do an accurate forecasting and allow you to make the decision in a timely manner. I will stop there, and yep, at the end of it, we are happy to take some questions.
Excellent. Looks
Thank
like we
you.
have a few already.
Yeah, Sally, take it away.
All right, we have one from Nick Giantos. Genesis, there we go. He says, I know the majority of Canadian wells have surface casing vents, as Dwight outlined in his slides. Are SCFs as common in wells in the US and certain drilling areas, or is this one more unique to Canadian wells? So that might be a good question for maybe Curtis.
Yeah, maybe Curtis or even Dwight, maybe since
Dwight,
Dwight does a
yeah.
lot of work in
Yeah, in
Pennsylvania.
Canada and
Yeah,
Pennsylvania.
I mean, I'll just give a quick notion on that, and yeah, so surface casing vents are certainly present in the US. They're not as uniform as they are in Canada, which is a problem. And there are certain states as well that require surface casing vents to be shut in, not to necessarily be open and or left open. And so it's a mixed bag, I guess, is what I've experienced in all of the states that we're currently working in. It's not certainly something that's standardized. So go ahead, Dwight.
Yeah, I can only echo what you said, Curtis. It's not standard. The ability is there, whether or not the actual candy cane vent is there, but I would say generally surface casing bowls you can tie into and measure from. There just may not be a candy cane vent there. I think the bigger issue is the inconsistency that Curtis mentions between regulator to regulator, whether or not that vent should be open or closed. All of Canada's regulators insist on that vent being open, and it's actually against regulation to shut it in. And it's designed as a weep port to show you have a problem with your well.
So Curtis, this next question is definitely for you from Les Skinner. You mentioned that pre-plugging methane detection in some length. And how about post-plugging and long-term monitoring to secure carbon credits, ACR protocol?
Sure, you bet. So, equally as important is the post-plugging monitoring. Typically, and we've got a couple of different levels of requirement under the ACR. There is a defined protocol on how soon after the well is plugged to measure, and then what are any requirements thereafter. Typically, there isn't any long-term obligation beyond the several months after the plugging. Kind of check the box and away you go. Under the IIJA program, it's even more truncated than that. It's a detect, non-detect. If we see an issue, then with the wellbore and it does have a presence of gas, and that initiates this whole litany of retesting with the potential of re-entering the wellbore. I'll tell you that we've had a 100% success rate in New Mexico, which has been fantastic. In our own plugging, we out of our 43 wells plugged to date, we've had to re-enter one wellbore, and that was extremely expensive, as you can imagine, and just anyway, not good on any level, I'll tell you that. But it's critical. And part of the reason, and I'll tell you on that re-entry that we did on the well done side, is that we had tested after the plug, and it had passed the ACR standard for that particular plug. But because the Well Done Foundation has a 10-year post-closure monitoring commitment to the landowners that we've made, we actually caught that on a subsequent visit. So after that initial period had passed, brings up a very interesting ethical dilemma that Dwight brought up earlier. It's like, did I really see that or not? And I would tell you that, this well was located in Erie County, Pennsylvania, out in a kind of a wilderness area. We could have just kept on walking. But it was the right thing to do. And so that, again, wouldn't have been found if it had not been for that elongated monitoring period. That's a voluntary program as part of our organization. Thanks.
Great, thanks. This next question from Dr. Clyde Tom Williams: how do you define an orphan well? Once built, are they considered improvements of subsurface properties? Ask a county assessors for property and improvements of property. Same with septic tanks and water wells. So how do you define it as an orphan well?
I mean, I'm happy certainly to answer this question. That by definition, an orphan well, and again, remember, we're talking about states' rights and state issues here, and so an orphan well, generally by definition, is one that no longer has a financially viable party associated with it. So no one who's in business or has any financing. Now, I would tell you that does vary a little bit from state to state, and it varies greatly from in the federal jurisdiction. We're working on several projects right now on BLM land, which is Bureau of Land Management, on the federal side, where if you ask the BLM, they don't have any orphan wells. And the reason they don't have any orphan wells is because they have record title holders or record title owners who are, until the beginning of time, where they just start peeling it back through the list, even though the well was transferred and, legally sold, and, all of those things that went along with it. They may even had a separate agreement with that defunct owner that said that they're assuming all liability. Well, the BLM quickly pierces that veil, and it's all based on the lease that they signed there. But essentially, kind of the down and dirty is there are no longer any financially viable parties. And in most states, then they just become a ward of the state. They fall on to the state. Now, interestingly enough, prior to IIJA, many states had a list of shut-in or idle wells, and the reason for that, and they still do, by the way, but those states tended to keep those wells in operators' names, even though the operators were no longer viable. It reflected better on them. Remember, this was everybody's dirty little secret, so nobody wanted to really come forward with the number of orphan wells that were in their purview. That's starting to change now with the advent of the IIJA dollars, which is good because you're getting a true assessment. But as I'm sure you'll hear at the seminar in Pittsburgh, there's also a whole nother wave of wells that are coming. And so that orphan well number of whatever it is, 2 million, is not a fixed number. And there is a wave, a tsunami, if you would, of wells that are hanging in the balance, that are marginal wells that operators have sort of in their portfolios today, that if we don't do something about those and provide an incentive for operators to deal with those, they will become orphans.
Got it. Susan, are we okay to go a little bit over the hour here?
Definitely.
Got several questions here.
Yeah.
Great. Yeah, so you kind of touched on this one a little bit earlier, Curtis. Another question from Jim Linville. Gas measurement for IRA or IIJA or carbon credit verification, is it actual leaks or the potential to emit, i.e. open the valve or use the last known product rates, and over what time period of years?
I would tell you that under IIJA, it's what's kind of leaking today. But what we see, remember, this infrastructure has failed or is failing, and I mean we see valves all day long that are where the gas pressure is extending beyond the integrity of that valve, or is extending beyond the integrity of the wellhead equipment. And so sometimes we're looking at a way then to find a balance of that flow. Every well is different, and so every well requires a sort of a unique rig up scenario. I wish it was all as uniform as Canada. It certainly makes the life easier. It makes the number of parts and pieces that we got to carry around with us less. But you have to be pretty darn creative. But you do bring up a really good point about the potential to emit, because you're absolutely right. That's a huge risk that isn't necessarily captured. So again, just because a well isn't leaking today doesn't mean that next week, same time, same station, it could be a whole different story. And I think that that's really important then to be able to identify, and certainly we are able to do that and have done that. And we find that it's best when it's done in a scenario of an active test over an elongated period of time, instead of just a point in time measurement or like a grab sample, something that extends at a minimum of 12 hours. So,
Got it. So a question here from Gary Randall: is there public data repository where the gas flow rates of wells worked on are recorded?
Gary, that's a good point. It's just starting. So first of all, remember that in the first round of federal funding under IIJA, the initial grants that went out, sort of those discretionary grants, which was like 25 million for each state, measurement of methane, quantification of methane was left as an alternative, or was left as something that was not compulsory part of the program, right? Which was unfortunate, because most states decided that they didn't want to capture that data. They wanted to plug more wells. Well, the reality is that was a huge miss of all of the wells that got plugged under that first round. That data wasn't captured. Maybe somebody went in and did a presence of, right? So either detect, non-detect. I know some states have done that. So unfortunately, after that first round, very limited data then that exists today. I know there's a lot of discussion currently under this next round, the formula grant round that's just being awarded and released now. The Department of Interior has made that a requirement. Interestingly enough, of course, there's some legislation that's been posed that would make that an alternative again. And we hear from organizations of all kinds that it really should be left up to the states to determine. And I would just tell you, it's a huge miss. So there is a move, though, to have a sort of a national database. And certainly states like New Mexico and others, and even ourselves, would likely voluntarily participate in that, just because of all of the wells that we've measured and all of the wells that others are measuring. That data is really important to see what those impacts are. Thanks.
Yeah, that makes sense. Maybe this question for Dwight from Jonathan Kahn. In the context of evolving gas measurement leak detection technologies, how does OGI compare as a long-term solution against emerging methods, especially considering its current limitations in sensitivity and quantification? And could advancements in OGI technology potentially bridge the gap, making it more comprehensive tool for both detection and quantification of methane emissions on site?
I'll do my best. I'm certainly not an expert on optical gas technologies. I think that technology, the little bit that I pay attention to it, is a rapidly evolving space. I think the Achilles heel of all of it to date is that it's still depending upon an algorithm to come back to this much wavy lines equals this much gas. I still contend, and it's certainly coming from a 100% biased perspective, because I sell a device that measures gas flow, but I still contend that if you actually want to get to a proper measurement, you need to get that flow through some sort of measurement device that'll actually give you conclusive measurements. But like I said, it's a rapidly evolving space, and there's better and better technology coming all the time. I think there's some interesting developments coming around ongoing monitoring. But I think what I've seen that's most encouraging out of that space in the last couple of years is a willingness for people to come to the table, and it's not a one-size-fits-all solution. Let's use the satellite observations to kind of narrow where we start to shine the flashlights, and then use the optical imaging to narrow that even further, and then get it down to what is the actual source and measure that source. I think that's the right approach. But again, as the technology evolves, maybe that changes.
That's right. Yeah. Question here from Les Skinner. Do any of you anticipate that testing old P&A wells to check for flow post-plugging, i.e. zombies? We're seeing this more and more often in Oklahoma and West Texas.
You know, I'll just touch base on that, because I certainly have seen the impacts of those firsthand in West Texas. For sure, it's a real thing. I mean, it's happening, and there's all kinds of contributing factors to that. You know, well plug integrity is a big concern. The development of well plugging materials. Advancement in that space has, you know, really needs to continue to evolve. You know, at the last conference when we were in Oklahoma City, there was a lot of discussion about well plugging integrity in geologic timeframes, right? Which is hard to wrap your head around, but it makes sense. And I would tell you that in places like where we're at right now in Southern California, where, you know, thousands and tens of thousands of these wells have been plugged with very little to no record keeping, and entire subdivisions have been built over the tops of these things. This is a huge potential problem. So yes, I would tell you that there needs to continue to be ongoing sensitivity and monitoring around that, and a continuous advancement in plugging techniques to ensure the best possible outcome for the longest possible period.
Wow. Yeah, that makes sense.
I could probably, Les, if you're looking for something specific to kind of guide that, go to the Alberta Energy Regulators Directive 79. It was a directive specifically put in for what they call urban wells. So it's an annual testing expectation around wells within an urban environment. We do hundreds of those tests every year, where my guys are crawling underneath decks and, you know, digging underneath foundations of garages and things like that, so we can test wells. But to Curtis's point, it's a monumental problem that's coming because we've expected our downhole barriers to last in geologic terms, and they just don't. We're asking rubber, cast iron, and cement to do things that it just can't do.
Yeah, so this last question is also tied into that question of transparency, right? And data around wells, from an anonymous participant asking, as a regulator in Canada, what are some of the benefits of methane quantification other than being able to communicate and promote plugging high risk wells to the industry in simpler terms? For example, by plugging X number of wells, we were able to reduce methane emissions equivalent to Y number of cars. So Neil, do you want to take that question? He's asking, what are some of the benefits of methane quantification other than being able to communicate and promote plugging high-risk wells?
Sunil, you're muted.
Yeah, I was muted, in fact. So not exactly my area of expertise, Sally.
Okay. Curtis, Dwight, do you want to tackle that one?
Yeah, I mean, certainly the decision making is critical. You know, the ability to use that data then to communicate the benefits is critical, and you know, just in terms of transparency for people to understand what the true impacts are. I mean, I'm continually astounded as I find myself in these different areas across the country and see the condition of this infrastructure. that's been in that condition for literally for decades and decades. And then you think back over the time period, you know, as this industry has evolved, and it's just like any other industry that, you know, and look, we all know that this is oil and gas is probably the most regulated industry in the world today. And you know, that's great because we've got some really great operators. We also have some really not great operators, and those really not great operators over time have made it really difficult for all of us. But I do think then that the ability to continue to show compliance with some of the new regulations that are coming our way, and it's like a freight train, I don't think we're going to stop it. It's kind of the cost of doing business, right? I mean, it's the social license, if you would, to produce. So, you know, I think it's time to embrace that. Of course, you know, I say that because we're in the measurement business, but it's time to embrace that as something that we all need to participate in and provide that data to show that social license to produce.
That's right. Now we have a handful of questions here in the comment box. I'll read off a couple and you guys can take them on as you see fit. BLM has in excess of 100 wells that are in need of plugging in the National Petroleum Reserve, Alaska. Then a question here from Curtis. Has there been any thoughts to putting these orphan wells back into production? And then another question from Don. What's the average cost of quantifying methane at orphan well site?
Well, you got all the easy ones there, huh? Goodness gracious. Well, you know, I'll take the easiest one first, which is what's the cost of measuring methane? You know, we've had a lot of discussions with elected officials and regulators about what that cost is and what that cost should be. For so long, there's been a lot of pushback about measuring methane because it's just too darn expensive. Well, I think we've shown that we can get that cost down to be more of a rounding error on the cost of the plug than an actual line item. And that was our commitment to Senator Ben Ray Lujan's office, that we would be able to do that. So instead of, you know, and again, it depends what type of a program. If you're in a measurement regime, for instance, for the American Carbon Registry, it's much more expensive because you have to have many more measurement sequences in order to be able to come up with your baseline, if you would, versus what's happening now for under the IIJA program. But the key is that it's not expensive. It should be less than, for pre and post plugging, it should be less than $5,000. And again, a lot of it depends on how many wells you can do a day, and you know what your crews are capable of, and all of those things. I mean, we've had projects you know, where we participated, for instance, for the University of Kentucky and KGS, where we measured 2 wells per county, right? That was the scope of work. Well, obviously, it's a lot different than working in the Permian Basin, where you can watch your dog run away for a week, and the next well is 500 feet away, right? And so, but at the end of the day, you know, we should look at that as being, again, just the cost of doing business, if you would, and it needs to be included. So that's, I guess, is my thoughts on that particular program. And then the notion of re-entering well bores, you know, we get that a lot, right? And believe me, I got lots of trolls out there that follow us around and give us a bad time all the time. The reality is, look, if these wells were re-enterable, somebody would have re-entered them, right? Their time period to step up to the plate and do something has come and gone, and their 15 minutes of fame are done. The reality is the landowners want nothing to do with it. The mineral owners are gone. Any kind of a savvy operator is not going to take on the liability of some sketchy wellbore with unknown integrity. And so I think that discussion is, while it does make sense in certain areas, by and large is probably that time period it is past.
Great
Yeah,
answer.
I could sum that up too, Curtis, with it. These wells were not economic at $200 a barrel. How are they economic at 70? They're just not.
And also, one thing to keep in mind, in terms of orphan wells, they haven't been producing for a while, so their leases have expired. So legally, nobody can do anything.
Yeah, that makes sense.
Well,
So
this was great. Do we have any more questions?
Yeah, we
Any more
do.
questions, Sally?
Yeah, let's take a last one here.
Okay.
From Curtis Willie. What, if anything's being done to replace cement as a plugging method?
I think there's probably a whole conference on that alone, Curtis. There's you know, I hear things all the time of some different clay type products, silicate products, the bismuth products. There's a ton of things out there. I think there's a lot of people looking at it, but I think it's kind of in its infancy. I think the good news in this, I think, is that there's more and more of us in industry starting to talk about the fact that there needs to be something and somebody needs to start working on it.
Excellent. Thank you all. Excellent presentations today.
And Sally, I want to thank you very much for facilitating the questions and answers. And do you want to say a little bit about Envana software?
Absolutely. So I'm with Envana Emissions Management Software Solutions. We're a leading oil and gas platform for reporting, tracking, measuring, and forecasting emissions. And looking forward to being at the AAPG conference later this month with Susan and the rest of the folks to tell you more about our software solutions and also how we're helping to to track and measure and report and take advantage also of the opportunity at hand. So thank you.
Thank you. That's great. And so we heard from Dwight and Sunil and Curtis, and each one has a different role in this whole process of taking care of the orphan wells. And I was really fascinated by the issue of planning for the liability too. And I think that Sunil, your presentation was really a useful and forward thinking addition. So I want to say thank you for that. And then Curtis, it's really great to hear the experiences from the field. I know of a couple of people who consider you their hero because you went in and plugged wells on BLM property and they were going back to owners that were like 5 different generations back in the ownership chain and threatening to basically seize everything they owned almost. I mean, that's the way it was represented to me, and you saved the day. And then Dwight, your work with borehole integrity is just really critical, and I think it's so exciting that you're in Canada, but also working in the United States. So that's great that you're having that kind of success. So I want to encourage everyone to attend the event in Pittsburgh on February 27th through 28th, also followed with a course. And also would like to thank you for attending today. You will receive an email with a link to the recording and also an announcement for future webinars. So thank you again. And I want to just wish you a very nice afternoon. Bye, everyone.
Thank you, Susan.
Thank you. Bye-bye. Good afternoon.